Hello everyone. So in this media and henceforth we are going to start some topics on electrical, okay, MET, marine electrical technology. And because first of all, thank you for your constant support, and which it really boosts our morale and it's really help us to do something better for you all. So I was receiving requests from people for covering because on electrical topics. So henceforth in upcoming videos we'll be covering topics related to electrical. Okay. So in this media we are going to discuss about electric shock and hazards. Some of the electric shocks and hazards that are related, and specifically that goes for marine and on ships. So, when we speak about electrical hazards can cause human injury in two ways. One is by electric shock and other is by arc flash. Okay. So I have compiled this content from different sources. I have made it in like a PPT so that it is easily so that you can easily understand it, and my idea is to bring the content surveyor asks questions under one umbrella. So electric shock, when we speak about, it occurs when body becomes part of an electric circuit. Shocks can happen in three ways. So when our body is also starts acting, or the current starts to flow through our body, then that is an electric shock. That is a state of electric shock. It can occur in three ways. Shock can happen in three ways. A person may come in contact with both conductors in a circuit. A person may provide a path between the conductors and the earth. Okay, conductors, either you come between the conductors or you come provide path between the conductor and the earth. A person may provide a path between an energized equipment and the earth. The extent of injury accompanying electric shock depends on three factors. So what are the extent of injury? The amount of current conducted through the body, the path of the current through the body, and the length of the time a person is subjected to the current. So as soon as you are going to act, the chances for the person getting saved, you increase the chances. You actually increase the chance. Now the amount of current depends on the potential difference and the resistance. The effects of current on the human body ranges from a temporary mild tingling sensation to death. So templing mild sensation, and that can go up to death. Okay. So when we speak about sorry okay, now an electric shock can occur in three ways. There are three ways by which an electric shock can occur. A severe shock can stop the heart or the breathing muscles, or both. The heating effects of the current can cause severe burns, especially at the point where the electric leaves the body. Other effects include severe bleeding, breathing difficulty, and ventricular fibrillation. In addition, you may have some other accidents as a result of the shock, that is, fall down or strike against something causing additional injury. Now, when we speak about arc flash, an arc flash is a release of energy caused by an electric arc. The flash causes an explosive expansion of air and metal. So that expansion is very deadly. It's like a blast. So the conducive material is vaporized by temperature in an arc, which can be as high as 35,000 degrees Fahrenheit. The blast produces a dangerous pressure wave, a dangerous sound wave, shrapnel, extreme heat, extreme light. Three dangers can result in blast injuries: lung injuries, ruptured eardrums, shrapnel wounds, severe burns, and blindness. Arc flash injuries can also result in death. They can also result in death. Protection from arc flash. Protection from arc flash is afforded by protective clothing and equipment such as wearing arc rated clothing, flame resistant eye protection, arc rated face shield in often required as well, hand protection, hearing protection. Training ensures that employees are thoroughly trained in safe work practices and procedures. Proper signage and labeling. Warning labels and signage on power panels, high voltage and machinery, and power lines are extremely important and can help to ensure that employees take proper preventive measures before beginning working or on or near potentially dangerous components. Now, basic safety rules. When we speak about these basic safety rules, all electrical circuit conductors, bare or insulated, are assumed to be energized until proven otherwise. They shall be de-energized, locked out, and tested for the absence of voltage before working on them or working near them. Work on electrical circuit conductors may only be performed by qualified personnel who have been authorized to do the work. Now, working on live circuits shall only be done by qualified employees who have been trained to recognize electrical hazards and have been trained to avoid injury by using safe practices, precautionary techniques, and protective equipment. Now, that is the reason why we are doing this high voltage course, wherein you must have seen, you must have seen all these equipments. Also, there is a separate video on high voltage, definition of high voltage, what is low voltage, medium voltage, and high voltage on ships, what are the protection, everything that is there in my separate video in electrical playlist. You can find that. Basic safety rules. Electromagnetic induction can create an electric current in a dead circuit. The condition occurs when a magnetic field from another wire, circuit, or device cuts across a wire in its path and produces a charge in that wire. Temporary grounding will prevent electromagnetic induction. Take care while removing a capacitor from a circuit. A capacitor stores energy, and if not properly discharged when removed, it can easily cause an electric shock. Always use a circuit breaker or fuse with the appropriate current rating. Circuit breakers and fuses are protection devices that automatically disconnect the live wire when a condition of short circuit or overcurrent occurs. The selection of the appropriate fuse or circuit breaker is essential. Normally, for protection against short circuits, or a fuse rating of 150% of the normal circuit current is selected. Never put water on fires in live electrical equipment or wiring. So what type of extinguishers that we are using? Basically what is suggested is DCP and CO2. DCP, in extreme cases when you can't find CO2, you can use DCP, because after using DCP, the circuit will be of no use, because that will penetrate inside all the circuit and it's hard to clean. Water is a conductor and increases the risk of arc flash and electrocution. An electrical fire is confined space, can rapidly deplete oxygen and may release toxic fumes. If possible, switch off power. Avoid inhaling fumes and vacate the area at once. If necessary, breathe through a damp clothes. Use a Class C fire extinguisher intended for electric fire. Now see, for on fire there are many live videos from Videotel, and also on the definition of the fire, fire triangle, fire tetrahedron, classes of fire, okay, everything, what is C class, A class, B class, and all these things in two categories, those have been covered in a separate video. Use a Class C extinguisher. Every worker who may be required to use the fire extinguisher must be trained in its use. That is why we are doing this firefighting course. All personnel using protective equipment must be properly trained and advised of its limitation. This can be classified as follows: head protection, safety helmets, hearing protection, face and eye protection, goggles and facial shields, respiratory protective equipment, dust mask, breathing apparatus, hand and foot protection, gloves, safety shoes, body protection, safety belt, apron. Now, use only approved test equipment and test probes during troubleshooting and repairs. Carry out proper maintenance of equipment according to the ship's planned maintenance system. Ensure that all guards, covers and doors are in place and securely fitted. Effect of an arc flash, arc blast. See, electrical arc, 35,000 degree Fahrenheit as we told. Now see, these are what's it? This is the one that's see what all intense light will be there. Copper vapor, solid to vapor expands by 67,000 times. So imagine what sort of blast it will happen. Hot air, rapid expansion. This is hot air and that is rapidly expanding. Okay. Now we have sound wave, pressure wave, molten metals, shrapnels. So these are the shrapnels that will come out, that will penetrate like bullets. Effect of electrical shock. Swollen tongue may obstruct airway. That is the reason why in our when we are doing this medical first aid, the first thing when you are doing giving this anyone CPR or any first aid, the first thing that we are, if any person is unconscious, the first thing that we are supposed to check is ABC, that is airway. First thing is airway, because the tongue will twist and it will not allow your CPR or your air to go, and it will obstruct the passage. Vision problem, irregular heartbeat or cardiac arrest, restless or irritable loss of consciousness, possible convulsion, paralysis, exit burn, difficult breathing or respiratory arrest, muscle tenderness and possible twisting, entry burn, that fractured bones. Okay, all these problems that are going to occur. Effect of electric current on human body. Now one or less, no sensation, probably not noticed. If we are talking in milliamps, remember this, okay? 1 to 3 milliamps, mild sensation, not painful. 3 to 10 milliamps, that is painful shock. 10 to 30 milliamps, that will muscular control could be lost or muscle clamping. 30 to 75, respiratory paralysis. 75 milliamps to 4 amps, that is ventricular fibrillation. Over 4 amps, tissue begins to burn, heart muscles clamp, and heart stops beating. Okay, so that is the gravity. So imagine all our motors, all the equipment on board ships, how much? Hardly, there are more than 4 amps. So we have to be very cautious. Imagine cargo compressors and imagine cargo pumps taking so much of amps. Resistance values. Current is the killing factor in electrical shock. Voltage is important only in that it determines how much current will flow through a given body. Resistance. The following values are given for human resistance to electrical current. Types of resistance, that is dry skin. See, so that will range between 1 lakh to 6 lakhs ohms. Wet skin, that is 1000 ohms. Hand to foot, 400 to 600 ohms. Ear to ear, that is 100 ohms. If skin contact in the circuit is maintained while the current flows through the skin resistance gradually decreases. So that is the whole idea and whole together that you must have seen, that what is electrical hazard, what is arc flash, what are the electrical injuries that could happen to, if ranging from what values of ohms and all. So how much what we are going to feel and how much shock we are going to get, the depth and the gravity of the shock. So I hope it is clear for you. We'll continue making videos on electrical topics. Thank you so much. Thank you for your support once again. All the very best for your future endeavors.